Hello everyone. Today we are getting into a new lesson on operations with radicals. And so if you recall, an expression sign is not simplified if a radical is in the denominator. So for instance, if I had 3 over the square root of 2, that would not be simplified because I have this radical in the denominator. And so to get rid of that radical, we do something called rationalizing the denominator. And what that means, we're getting a square root out of the denominator. Or in other words, a radical out of the denominator. And to do that, we're going to multiply top and bottom by a number that produces a perfect square. Under the radical sign in the denominator. So let's kind of talk about that for a little bit. So going back to this previous example of 3 over the square root of 2, I want to get rid of this radical, and what I need to do is I need to create a perfect square under there. And so since I have 2, I really want this to be equal to the radical square root of 2 squared at the bottom. So to do that, all I need to do is I need to multiply top and bottom by the square root of 2. So I have 3 square root of 2 on top, and then square root of 2 times square root of 2. Well, 2 times 2, that's just the same thing as 2 squared. Now let's see what happens when we have that. Well, I have 3 square root of 2 over 2 squared. That's just 2 times 2, which is square root of 4. Well, the square root of 4 we know is 2. And so that would be my simplified version. So something special with radicals is that when we multiply a radical by itself, we just end up with that number inside the radicand without the square root. That's the case every single time. So if I had the square root of 7 times the square root of 7, that's just going to equal to the square root of 49, which is in turn equal to 7. And this is because the square and square root are inverse operations, so this is going to happen every time.